Hello, welcome back to IT Landy Nugget courses. For today, the main focus will be around PKI and the modules or the sessions will cover the following. Quick introduction and background, PKI concept, and then we have from 1 to 5 sessions around hardware security, bring your own key, virtual smart card, network device enrollment, and then secure your admin workstation. The foundational concept of PKI. So what we will cover under this section: system architecture, physical design, management roles, backup and recovery, update, patching. System architecture. This is very crucial when it comes to design your PKI. Let's have a look. So what's the main structure for our PKI? We have the certificate authority, and usually it's called CA. Trust relationship among the CA are based on the hierarchy. So you go the root CA, and underneath the root CA, if you look at the structure on the right hand side, you have the sub CA1, 2, and 3, and so on, depend on how many of them you have the subordinate. The CA is either a root or subordinate, yeah? There's a typical only one CA, trust anchor, but there can be more. It depends on your requirement, yeah? Either, for example, I don't know, internal CA for maybe VMs if you want to, maybe you have for applications, it depends on the design, but we will cover this in more details. Root CA are normally offline. The subordinate CA can be either policy or issuing CA. Hierarchy are 2 tiers, typically, or it could be 3 tiers, depend on your requirement, and explicit offline policy CA are required. A CA can be either ENT or enterprise CA, which is domain joined, or it could be standalone. Again, depend on your requirement. We will cover this in more details. Some of the basic examples you can see on the right hand side. We got the root CA. What do we have there? We have the CA name, role, key length supporting this deployment, lifetime, and the CRL publishing, and the status, either offline or online. But we mentioned earlier, CA will be offline. I'll cover that later on, why they need to be offline, not online. And then you have the sub, which means subordinate, like CA1, 2, 3. And these, they have different lifetime as well, depending on your requirement. And the user authentication is like, for example, certificate based. It will be the encryption itself, the issuer, and the name. We'll cover this in more details, but this is what the concept behind the CA. Now, the certificate authority design decision. This is really crucial when it comes to you to design, your CA. What you need to do and how you do it. To start with, the root CAs, we have one, we said, or more. It can be online or offline, and can be enterprise or standalone. Now, these are the decisions you need to make before you deploy. Root CAs represent the number of the trust anchors required, typically one, but can be more. Online or offline, root CA are typically offline, but there's no harm of bringing it online. Root CA are typically standalone due to the fact they are not, they are also like, because they are offline, you don't need them to be domain joined. Policy CAs, you can have, as much as you wish policies. Policy CAs are not typically needed, but if you are captured, why you need it. Again, policy servers, either online or offline, typically offline, similar to the CA. Policy will be offline. Enterprise or standalone is typically standalone because offline, similar to the previous one. The next crucial part which is the issuing CA. This is the one which you consume. Again, one or more can be, failover, available, HA, whatever you want to do, all these reasons. Typically, you have at least two, in my opinion, to take care of the HA. Again, it's online, not offline this time, because it's issuing certificate to the machines or it could be users. And this time we need to have it enterprise domain join to make sure it's available. So this is the different. The policy CA are not generally recommended or used anymore, as most functionality can be replicated, and collapsed onto an issuing CA, which is the online one, yeah. And that will basically save you like another surface. And as I said, this offering assume two-tier hierarchy, yeah, with no CA. We can cover this later on. We're still under the concept. Now the path length constraint. The path length constraint, I've highlighted for you guys so we know which terminologies are critical when it comes to CA. It's a basic constraint for CA certificate that specify how many levels of CA can be subcoordinate or subordinate from and where and below any CA required. And constrained blank path length is typically used for the root CA. This allows the extension of PKI in any way required in the future, but only from the highly secured offline CA. You can utilize zero path length, typically for issuing CA, meaning that the PKI hierarchy cannot be subordinate further from them. You see what I mean? So if you think about it, top CA, if you put C0, which means you can just like have underneath subordinate, you cannot branch out from it, if that makes sense to you. However, different issuing CA may have different requirements depending on the use or use cases. This is the table which will help to decide on the path length constraints. Yeah, we will do the same thing with every feature with the PKI. We will talk about it and then we'll have a table. The root CA, we set path length constraint and constraint blank basically. Path length is typically used for the root CA. This allows the extension of the PKI hierarchy if needed in future. Issuing CA, the one which is online, if you remember. Path constraint 0, yeah, not blank. Path length is typically used for issuing CA, meaning that the PKI hierarchy cannot be subordinate further from there. Yeah, you cannot branch out from it, as they are online and less secure than the offline route CA. However, different issuing CA may have different need or requirement, and so on. CA2 all the way to CNN, CAN, which means all they need to be following the same footstep here. Next, the certificate cryptographic algorithm. Again, cryptographic algorithm. Remember, path cryptographic algorithm and the hierarchy. The cryptographic algorithm are well-defined, mathematically complex process or sequence of rules are used to convert plain text into ciphertext and vice versa. Security, basically. Cryptographic algorithms provide the building blocks for all the cryptographic functionalities such as private, public, pair, encryption, hashing, and digital signature. A hash algorithm and encryption algorithm need to be decided, typically SHA-256 and RSA 4096. These are the commonly used and recommended at the moment as a minimal requirement. Again, similar to the previous ones, a table. We need to decide about the cryptographic. Root CA, typically SHA-256 and RSA unless requirement exists. Issuing certificate, again, similar to the previous one, typical 256 and RSA unless other requirement. And entities, typically 256 RSA unless other requirement, but can be decided on per certificate, per template, if that makes sense to you. So the top 256 RSA, the issuing certificate subordinate, again similar, and the last one similar, but give you flexibility on how you can control it. Okay, that's all what I have for you for session one. Let's we catch up on session two. Thank you for watching and goodbye for now.